Hello all, welcome to the ISF Think Beyond session. I can see we have many attendees joining now. Welcome and thank you all for joining us today. It's my pleasure to get to present to you some of our latest research. I'm going to give it just a minute to let everybody join in. And I'll make sure that all of our systems are nominal so I can see the chat is working. This is a good start. Uh, it's great if you say hello, where you're joining us from. It's always really awesome to see because we have people joining from all over the globe. We have a global community that is just really fantastic that we get to share this kind of information with so many different kind of viewpoints and perspectives with people coming from all over the globe. And it just kind of speaks to the amount of interest there is in uh, developing unified science that reveals some of the uh, uh, deeper aspects to the nature of reality, which is one of our goals here at the International Space Federation. Mm. In terms of the goals of the ISF, International Space Federation, uh, you all know the primary mission objectives, so to speak, which are development of gravitational control technology, harnessing zero point energy or the energy of the quantum vacuum fluctuations, the quantum vacuum energy density of the electromagnetic field. Uh, these are all um, technological breakthroughs that we see on the horizon now that some of the main solutions to understanding the fundamental interaction of the fundamental forces is elucidated, such as the gravitational interaction, electromagnetism, and how they interrelate between the two, those two as an example of fundamental forces, that if we can understand their interrelationship, we can harness, we can use one to harness the others, such as, with the skill that we have in uh, harnessing electromagnetism, we could use that to uh, engineer the space-time metric for gravitational control technology, or even to induce high coherent domains of the quantum vacuum fluctuations of the electromagnetic field to harness energy. But one of the additional interests we have at the ISF is in getting a better understanding of the nature of the biophysics underlying the living system. And that's one of my primary involvements with the International Space Federation is applying some of the solutions that have been developed in that unified field theory to better understanding the biological system. And that's what I'll be sharing with you today. Actually, some of our most recent work, breakthroughs that have come about in the last few months. So I'll be sharing some of that information with you today. So I'll get this started. Okay. So uh, I'll be looking at uh, our application of some of the solutions that can be found in, for instance, the paper, The Origin, Mass, and Nature of Gravity, and how we have um, found a cross-scale resonance mechanism that scales from the Planck scale of the quantum vacuum fluctuations to the mesoscopic scale of the biological domain with like the brain. So a Planck source frequency drives coupled oscillators across scales, generating collective modes in biological macromolecules. So the ground state of the electromagnetic energy of the quantum harmonic oscillators, or zero point energy, has been shown to play a significant role in atomic processes, from being a source of the underlying stability of matter to light matter interactions, and at the cosmological scale with the cosmological constant and Unruh Hawking radiation. Here, we identify a mechanism in which the ultra high frequency oscillators of the electromagnetic quantum vacuum fluctuations couple across scale via angular momentum conservation from fine scale spacetime dynamics to the biological scale of molecules and cells. This characteristic coupling constant defines a universal scaling factor that correctly and accurately predicts the vibrational frequencies empirically observed and measured from carbon atoms and benzene ring aromatic hydrocarbon molecules to the triplet of triplet frequencies measured in microtubules, microtubule bundles, neurons. And so we actually even output the gamma oscillation range for neurons. And so this is a very remarkable cross-scale frequency resonant coupling mechanism that outputs nearly precise frequencies that are measured for a variety of oscillatory systems that have a surprisingly large magnitude of scale difference. So it's really just actually, I'm astounded at how this mechanism precisely describes the energy characteristics of these systems as being sourced in a Planck source frequency, ultra high frequency, low entropy mode of the quantum vacuum energy density. So we identify this mechanism of coupling of quantum harmonic oscillators from the Planck scale to the biological scale. As such, vibrational energy transfer is described within a nested architecture of coupled oscillators. And I'm going to be going over this in all detail. This is just kind of an overview, give you an idea of what we're going to be looking at today. So these findings describe the role of quantum vacuum energy in coupling molecular oscillators and being the source of the non-classical, non-trivial quantum states that we believe have been experimentally observed in biological macromolecular networks. This suggests that these states are more common and more robust than would be presumed in models without a driving source like the zero-point energy coupling we have computed. There's a source that's driving this long-range collective activity that, in many instances, is a quantum coherent state of the macromolecular system of the cell, which without this driving source would seem to be rather a tenuous state to maintain long range coupling in such an presumably noisy system as the cell. So these findings open the door to new biophysical insights, implying a significant role in dynamic quantum fluctuations at the biological scale. Now, one of the exciting developments is that me and Nassim recently presented some of this information at the fifth Aquaphotomics conference. That is a conference focused on the quantum electrodynamic nature of water and how to study water matter interactions from a quantum field theory perspective. And during leading up to this conference, and during the conference where we had an opportunity to speak with and collaborate with a number of just brilliant physicists and photometer specialists who actually investigate empirically water, we have also done some in-depth research into the role of water in this architecture of nested oscillators coupled to the ZPF. So in our recent research, we elucidated a crucial mechanism for electromagnetic quantum vacuum fluctuation coupling operational in the self-organizational dynamics of coherence domains of water. Here, water molecules act as effective zero-point field antennae, resonantly activating the OH bond of water, driving the formation of coherence domains. And I'll explain a little bit more what that means later in our discussion here. Um, which are veritable, these coherence domains coupled to the zero-point field or the quantum vacuum fluctuation energy density become veritable negentropic converters, lowering the entropy of the dissipative system of the biological organism. From our origin of mass formalism, we identify a coupling mechanism from the Planck scale quantum vacuum fluctuations, generating the proton mass and confining forces, and apply this coupling mechanism to the molecular scale, where we find that it appears to be integral to zero-point energy stabilization of the OH bond stretch mode of water, and is particularly pronounced in the hydronium ion, which is H3O. And the hydronium ion is common in ordered phases of liquid water, and living systems, where there's many instances where you have a high concentration of, let's say, delocalized protons. This is particularly characteristic of the mitochondria, where you have a high concentration of free protons, and those are housed, so to speak, as hydronium ions, which engage in a pretty interesting um, uh, uh, ionic bonding, hydrogen bonding patterns of the water matrix in those states. So it's very characteristic of the living system. Vibrational resonance energy transfer of zero-point energy to the OH bond results in a characteristic frequency near the measured value of water. That's one of our main discoveries, which is really fascinating. This Planck coupling mechanism gives us nearly the exact frequency of the OH stretch mode for water, but it also gives the nearly exact frequency of the oscillation of aromatic amino acid, the benzene ring structure in microtubules. So the giant resonance of the carbon nucleus. It's really pretty fascinating. But this mechanism illustrates how localized proton structuring in aqueous environments can dynamically initiate quantum coherent domains and regulate intermolecular organization in biologically significant systems like microtubules and in mitochondria, as mentioned, where proton gradients drive biosynthesis of cellular energy. And one of the things that we're saying in applying this understanding to water is how the proton, which actually plays so significantly in water, is really has a function potentially of being like the source uh, for the source particle for this negentropic field effect, like a source particle for increasing the coherence of interacting systems, and exchanging the low entropy, ultra high frequency energy of the quantum vacuum coherent phases into the surrounding medium. I can maybe explain that a little bit more clearly as we go along. But again, this is kind of like uh, really recent discoveries that we've made. So this is kind of breakthrough research that I'm sharing with you here. So it connects Planck scale physics to biological functions through water, positioning coherence domains of water as quantum transducers of the vacuum. So this could potentially demonstrate how water functions as like a biological cavity resonator, a negentropic converter of the low entropy uh, uh, quantum vacuum energy density into the biological system for self-organizational dynamics, utilizing those coherent vacuum modes to self-organize. I think that our last few sessions have been with our physicists, our brilliant physicists, Cyprien Guillemont, uh, Olivier Olriol. And so they've probably, I would imagine, gone over the solutions and results of the origin of mass, nature of gravity, and even some of their most recent research into the origin of mass and nature of gravity with you. But just to recap, because to understand this Planck coupling mechanism, we must understand, at least in a general sense, what is zero point energy, how does that relate to the quantum vacuum? Because 0 point energy as I'll show here, is just a energy that characterizes any material system, even a quantum field, in its lowest energy state, in its ground state. So this was work that was or a discovery that was made by Max Planck, um, 120 some odd years ago, where he's looking at the total power of a material system that is a radiative system. Actually, we're looking at idealized black body radiator. And then what he discovered is that if with any material system, if you bring it down to its ground state energy here, so let's say near absolute zero temperature, 0 Kelvin, it retains this 1/2 h bar omega energy value. That is 0 point energy. And this discovery actually kind of initiated quantum mechanics. Einstein went on to apply this to describe the photoelectric effect, of which he won the Nobel Prize, but to actually describe any oscillator. And quantum mechanics very much is a an approach, a formalism that describes harmonic oscillators. We can call those atoms, molecules, um, particles even, but it requires 0 point energy to describe accurately these oscillators. So the Planck coupling constant that we'll review is a system that is drawing, in a certain sense, energy from the quantum vacuum energy density, which comes from the fact that even the electromagnetic vacuum in its ground state has an energy, 1/2 h bar omega, 0 point energy. So you can even talk about a 0 point field, because the quantum electromagnetic vacuum, the field, has a non-zero energy value, even in its ground state. When all matter and all potential energy sources are seemingly removed, there's still energy there. And actually, if you sum across all potential modes, that's that frequency here, the omega, then you actually, the contribution of all these 0 point energy, they seem small contributions, but across all modes, you actually get an infinite energy density of the 0 point field of the quantum electromagnetic vacuum. And so, although 0 point energy can be, and actually is commonly mathematically removed from the Hamiltonian in quantum mechanics by normal ordering procedure, this does not mean that 0 point energy vanishes from the system. You can try to like kind of simplify the calculation by removing it and pretending it's not there, but you're missing the actual true physical description of the system by doing this. It works out okay mathematically, but you're not completely describing the complete picture of your material system or your quantum field, because you're describing harmonic oscillators. That is mostly what is the formalism and the approach of quantum mechanics is doing, not entirely, but in many cases, especially with your Hamiltonian. But in fact, the non-zero value of the ground state mode results from the non-commutative relationship between operators of the Hamiltonian, the creation and annihilation operators, and it's essential for the mathematical consistency of quantum theory. This can be demonstrated by considering a dipole oscillator. This is the equation for a dipole oscillator. This could be an atom. Let's consider this as an atom. An atom could be modeled as a dipole oscillator. Uh, but the resulting harmonic oscillator equation takes into account the radiation reaction field, which is a dissipative term. So the oscillator, it's moving around, it's dissipating energy. You got charges that are oscillating, it's dissipating energy. Um, and so without the 0 point energy term, when that's canceled out, when that's set to zero, your dipole oscillator will quickly collapse. It radiates the energy. It's a dissipative system. It goes to zero. And this is analogous to if there's no source term. This is analogous, so it goes to zero. This is analogous to the classical model of the electron, of the atom, where the electron will it's uh, it's a oscillator in terms of rotational frequency around the nucleus. And it's radiating energy in the classical model, and so it'll dissipate that energy and fall into the center of the nucleus. If we were to consider like a classical type model, one reason this doesn't happen is that there is a source term, the quantum vacuum energy density, which is continuously supplying energy, keeping these oscillators from dissipating, damping and dissipating and collapsing. So this is an important conceptual thing, is that there's 0 point energy that is maintaining the oscillation of material systems, of harmonic oscillators that are atoms, that are molecules. So that's an important consideration. And so thus the 0 point energy is a source term necessary for the stability of matter, counterbalancing the radiative damping of the dipole moment. So with your Hamiltonian, your creation and annihilation operators require that 0 point energy term, especially to keep them non-commutative. Um, and actually, what is shown in the Origin of Mass and Nature of Gravity paper by Cyprian, Olivier, and Nassim is that the 0 point energy is required to maintain that non-commutivity of the operators, which leads to the fact that the Heisenberg uncertainty principle, when you have that source term included, emerges from the quantum vacuum fluctuations. So here's that dipole oscillator with the source term included. It doesn't go to zero. It's not set to zero. And when that is included, the operators have fully non-commutative. And if you bring it to its solution, you actually can derive the Heisenberg uncertainty principle from the dipole oscillator, from or if your oscillators, let's say, are quantum vacuum fluctuations. So this is an important point, even more generally, just because uh, if you were to ask an AI, ChatGPT, for instance, what is quantum vacuum fluctuations? What is 0 point energy? It'll say, this is energy that comes from the Heisenberg uncertainty principle. And it's kind of universal. You Google that. You ask a physicist, it's energy that comes from the Heisenberg uncertainty principle. It's not. Uh, 0 point energy discovered by Max Planck was discovered almost 20 years before the formulation of the Heisenberg uncertainty principle. Just roughly speaking, those aren't exact numbers on the timing. Um, and actually, you can say that you could derive the Heisenberg uncertainty principle from the requirement in quantum mechanics for there to be a source term of 0 point energy. So Heisenberg uncertainty principle, in a certain sense, comes from quantum vacuum fluctuations. And in terms of defining intrinsic indeterminism of quantum mechanics, you can kind of think of it like, well, if there's a non-zero energy everywhere, and you're talking about like a particle, it's constantly absorbing energy from this 0 point field. So it's got a little bit of uncertainty in its velocity. It's probably kind of changing a little bit. Its position is kind of changing a little bit. So there is a little bit of perhaps intrinsic uncertainty because of the quantum vacuum fluctuations, not the other way around. Just a side note here. But so that's looking at like the historical progression of 0 point energy. But we also can look at the modern derivation of quantum vacuum fluctuations. Um, and this has to do with the correlation functions. I kind of gotta move a little bit quickly through this. Um, but you can imagine it if you have two parts of a wave, positive frequency part green, negative frequency part blue. This is kind of like your annihilation and creation operators in the Hamiltonian. When you add them together, you get the full wave, red here, which represents a real electric field over time. And the key idea is that the energy in the vacuum depends on how well these wave parts line up with themselves over time. That's called the correlation, and hence correlation functions. And you can look at when it's 180 degrees out of phase, there's no energy in the quantum vacuum, it's zero. However, when those correlation functions are at the 0 degrees in phase, you have a lot of energy, maybe even infinite energy density, which is what has been calculated even from the classical calculations of quantum vacuum energy density, the vacuum energy expectation value. So what the and the relevant part of this is that when you apply this correlation time tau as it gets closer to the Planck time, which is really just small time, it goes to infinite energy density. When you apply it to the proton, or let's say you can say at the Planck scale, that's the Planck interaction time. You recover the classical energy density of the quantum vacuum into renormalized value, rho vac. When you apply it tau with the classical interaction time of the proton, or how fast it takes a light beam to travel across the radius of the proton, when you apply that as tau, the interaction time, you recover the energy density of the proton. So the observed rest mass energy density of the proton is a function of the coherence of those quantum vacuum fluctuations, their phase. Or is it high coherence or low coherence? What is their phase relationship? And with a certain phase relationship defined by the interaction time of the proton, you get the proton rest mass energy density. And why this is very interesting is that that is a very simple, straightforward explanation coming from empirical evidence. Max Planck's discovery back in 1905 or whatever, the 0 point energy, and you describe 100% of the proton rest mass. Unlike lattice QCD and the Higgs mechanism, where the Higgs mechanism describes 1 to 5% of the proton mass, and the other 95%, whoa, uh, is due to the back reaction of color gluon fields resisting accelerated motion of the quarks and gluons inside, or whatever. Whatever kind of explanation is given to actually account for the proton rest mass that the Higgs mechanism does not account for. Okay, so another just important point um, is that this description of the degree of coherence of the quantum vacuum fluctuations and how it results in the observed rest mass of the proton. Well, there's also a screening that is at play in that decoherence that is defined by those correlation functions. Because as uh, the correlation functions become less correlated. You're now describing systems that are out of phase and hence have higher decoherence. And this is what is occurring if you go from the center of a proton outwards. You're going from a near zero entropy Bose condensate of those quantum vacuum fluctuations that are at almost perfect correlation coherence. And as you move outwards, you're getting a decoherence. And this accounts for the confinement forces, the strong force, residual strong force of the proton, what's holding it together. Um, and this is going to become relevant for our consideration of the Planck coupling constant and the 0 point energy transmission across scale and this nested architecture of coupled oscillators going from like the proton to the carbon nucleus to benzene ring molecule to tubulin macromolecule to microtubule bundle and neuron. There is this screening at play, which is kind of a decoherence, a mitigation of the strength of that zero entropy Bose phase, high coherence phase, and it has to do with decoherence. And this is just showing the screening that recovers the color force, the residual strong force, and then outside the proton, Newtonian gravity, the gravitational interaction. Uh, so, uh, with this in mind, we wanted to start to describe to a certain extent uh, or characterize those space-time voxels. So, we've described the source of mass and fundamental forces via the collective action of space-time voxels or little quantum harmonic oscillators and high coherence phases. Now we can look at what is the strength of the coupling of the quantum harmonic oscillators as we go from the zero entropy Bose phase, the high coherence phase, at the core of a region of extremely high coherence. See, I can even back up just a little bit here. That's our high coherent zero entropy phase there at the core. That's ROVAC. As we go from that, uh, so we're going to have a certain degree of decoherence. So if we're describing the coupling of those quantum harmonic oscillators in the Bose phase, what does it look like? The Planck coupling, the coupling of material systems to the quantum vacuum fluctuations as we go to larger and larger scales, which are also uh, at higher levels of decoherence, lower correlation time in those correlation functions. Um, well, what we do is, well, we can take the equation for even a classical harmonic oscillator, and this is just showing that um, a linear oscillator is equivalent in certain mathematical treatments to the realistic situation of a rotating oscillator, which is really what we're talking about. These are spherical systems that are rotating, or near spherical systems that are rotating. But we're going to use the equation for just a linear harmonic oscillator, like a mass on a spring, because it's equivalent to the rotational one. But this kind of simplifies the calculation. So we've got our space-time voxels, which are rotating vortices of the quantum vacuum energy density, the electromagnetic field, the polarized oscillators of the electromagnetic field, little black holes, actually. Um, and they have a rotational frequency of the Planck rotation, 10 to the 43 hertz, the Planck mass. So now we can look at, okay, what is their strength of interaction? What's their coupling? How strongly do these resonantly couple together? So how tightly held together is that Bose phase within the center of the proton. That's the kind of how this could be thought of to a certain extent. Well, it's a simple rearrangement of the equation for a Planck oscillator. We're wanting to look at the strength of that coupling term, the spring constant here, K. Um, it's a simple, mathematical rearrangement, inserting these values, and what we get is uh, the Planck coupling constant here, which has a very specific value. This is, in a certain sense, the strength at which the fundamental spacetime voxels are resonantly interacting and coupled together. Now, what's very interesting is that we can now apply, using this Planck coupling constant, can apply it uniformly across scale and see what happens. Now, obviously, when you plug it back into the equation, which we just rearranged to get the Planck coupling constant, it outputs the Planck frequency. But if you input it into the equation with the Planck mass and a screening term, so again, that decoherence term, it outputs a value that is a characteristic time of a quantum black hole. When you input in the mass of a quantum black hole with the Planck coupling constant and a screening factor, a decoherence factor, that's this alpha G 1/2, which is also Nassim's holographic constant phi or phi. You get the characteristic interaction time of the proton, or the time it takes a photon to traverse the radius of the proton. Now we can go to larger aggregate systems. So if you get four protons together, when they're in this state, two of them behave like a neutron for reasons we can get into later. But that's kind of the next stable particle from the proton. So the proton is a hydrogen nucleus. We're going to look at a helium nucleus, the alpha particle. When you plug in its mass and that alpha G or phi screening factor, you output very close to the calculated value of what's called the giant resonance or oscillatory frequency of the helium nucleus. We know the same with the carbon atom. This value is very close to if you had a textbook calculation of the potential oscillatory frequency of the carbon nucleus, it's very close to that value. And what is really surprising is that we get the same uh, precision for water. So there's two values here. One is just normal water, and this is actually the strength of the OH stretch mode, the oxygen-hydrogen bond on the water molecule, and this is its strength in the gas phase, which actually we're not entirely interested in because water vapor doesn't really have much biological activity. We're interested in the liquid phase. And actually, even more specifically, we're interested in the liquid phase in a strong hydrogen bonding environment, which oftentimes leads to delocalized protons. So we actually look at the stretch mode of the hydronium water molecule, hydronium ion of the water molecule. And actually, as I'll show, our computed value based on the Planck coupling constant is unbelievably close to the measured value of the OH stretch mode in uh, structured water, so to speak. Water with a strong hydrogen bonding environment, which is it's forming like dimers, trimers. So like water molecules that are covalent or ionically bonding together into geometric forms, geometric structures, structured water, albeit kind of like a dynamic fluctuation there. But and this goes on. The benzene ring. We have this illustrated diagrammatically here. Um, uh, the benzene ring or aromatic ring structures are very important for biology. These are light absorbing and emitting molecules. They also have very specific oscillatory dipole moments that have been shown even empirically to have long range coupling interactions within the macromolecular environment of the cell on, for instance, tubulin molecules, but we output very specific frequencies for the benzene rings, the tubulin molecules that form microtubules, microtubule bundles, the neurons. When we look at the approximate mass range of a neuron, interestingly enough, we get very close to the gamma oscillatory frequency of neurons, and the collective action of synchronized gamma oscillatory neurons is the oscillatory state of the brain. So we actually scale from the Planck scale, quantum vacuum fluctuation energy density, to the brain and output precise frequencies of oscillators all along the way. And what we're depicting here is that some of our most recent research is showing how water, in a very significant way, is at the nexus of this connection between the quantum vacuum energy density, the 0 point field, and the mesoscale of biological organization. Water is almost like an intermediary quantum field in and of itself, that is providing as like a negentropic converter, the organizational, self-organizational dynamics for macromolecular systems that lead to biology. And so between the quantum vacuum oscillatory fields of high coherence domains of the quantum vacuum fluctuations to biological organization, but also even mediating interaction between like small molecules and larger molecules and macromolecules. So we have this cross-scale resonance of a nested chain of coupled oscillators, and critically, we've seen the oscillation in OH bond for water is remarkably well fit. So just to kind of go over, right, what that table and that diagram is showing. So we had the Bose phase of this high coherence uh, core for the proton, which is more more accurately described as just a high coherence domain, a high coherence phase of the quantum vacuum fluctuation energy density. And with that Planck coupling constant value and the Planck mass, we output the Planck frequency. From that, we can see how going across this screening horizon, and we're quantifying the amount of that decoherence or screening via Nassim's holographic screening constant phi. We output the frequency for a quantum black hole. Then we see how that uh, quantum harmonic oscillator couples with cross-scale resonance to the next larger oscillatory system. So this is high frequency oscillators, little high frequency oscillators coupling to larger oscillator systems, transferring energy into like their base modes and boosting their overall energy and supplying energy to keep those systems oscillating. So applying that, we then recover the characteristic interaction time of the proton. Then when that goes across another screening mechanism, this time going from, subatomic scale to atomic scale, going from a single proton to multi-nucleon state, let's say the alpha particle of the helium nucleus, we output the frequency for that oscillator. Then if you get three of those and put them together, you have a carbon nucleus. So now we're going from a smaller oscillator to a larger oscillator. How does it couple to that larger oscillator, transferring that low entropy, high energy, the 0 point energy source to this larger oscillator, providing it the oscillator's energy so that it doesn't dampen and radiate all its energy and collapse the dipole. And so, and you know, these values can be matched to what is calculated in certain sources, and the values are remarkably similar, especially considering that we're scaling from 10 to the negative 35 meters, the Planck scale. So we're going across almost 34 orders of magnitude here, which is almost like the scale distance from here to the edge of the universe. So now we'll put six, so we put three of those together, three alpha particles together to get a carbon nucleus. We'll put six carbon nuclei together to get a benzene ring structure. Uh, Calculate with its mass, the mass of that oscillator, and the decoherence term, the screening term, and we output a terahertz frequency, which is the known frequency for benzene rings or aromatic rings. They're terahertz oscillators. And you study them with terahertz spectroscopy. Just nailed it. Um, and so these are super important for biology because they form these dipole oscillators. So they're involved in many molecular, intermolecular interactions, protein to protein interactions, interactions in the plasma membrane, nucleoside to nucleoside interactions. The DNA is a stack of pi electron oscillators. That's what's being depicted here. So there's these pi to pi interactions. So it's very significant, and we'll definitely be discussing more about this, sharing more information about this. And there's all kinds of ways that you get long range synchronization of macromolecules via these pi to pi bond interactions, the interactions of these dipole oscillators. So the fact that we're outputting the exact the general frequency, the terahertz frequency range of these oscillators shows that their functionality is dependent on 0 point energy contributions, the quantum vacuum coupling with the quantum vacuum fluctuation energy density. So that was the role of these benzene ring-like structures, indole type structures in DNA. Okay. All right. It looks like I'm running out of time. Um, so much interesting information. But so terahertz oscillations for those benzene ring structures. Then these benzene aromatic ring structures are in the microtubules. So here's a tubulin dimer. These are aromatic amino acids within it. These tubulin dimers form microtubule crystalline lattice, which form protofilaments, which form microtubules. And here, these red dots, these are all the aromatic amino acids, which form this mega network of coupled oscillators on the microtubule, or even actin filaments, which are really important for dendritic spine formation. And so the function of neurons, so this relates very much to consciousness. But again, so we output that terahertz value, mass of a microtubule with the decoherence factor screening value, gigahertz oscillatory frequency. That's what's measured for tubulin. Uh, Same procedure for microtubule, megahertz frequency. That's what's measured for microtubules. Certain segment lengths of microtubules. Get a microtubule bundle that is characterized as the axon of a neuron, which is absolutely integral for neuronal oscillatory function or signaling, and we get kilohertz oscillatory frequency, which is what's measured for the axonal bundles. And then applying that to the neuron, same procedure, we get about a 30 hertz frequency range, which is about the oscillatory frequency of the gamma synchronization pulse, which is very much associated with consciousness and whole brain synchronization. And again, what we're talking about with this oscillatory coupling across scale is long range synchronization. This is how the system acts as a whole. And it's coming from the quantum vacuum from the 0 point energy contribution. And so these are measured values, though. So just this is dielectric measurements of actual tubulin, microtubules, and neurons. And you can see megahertz, gigahertz, terahertz for tubulin, um, megahertz, gigahertz, terahertz, microtubule, gigahertz, megahertz, kilohertz, gigahertz, megahertz, kilohertz, which is exactly megahertz, kilohertz, hertz for the neuron, megahertz, kilohertz, hertz. So just a good agreement with empirically measured values. That's from our good friend Anirban Bandyopadhyay, who we were presenting with at this aquaphotomics conference in Japan just a couple weeks ago. But so then, just real quick on that, the significance of the water and that OH stretch mode. So one of the reasons why this is significant, and so I actually think I saw a question about this OH stretch mode. Let me see if I can pull up the questions real quick. Q&A. Um, Let me see. I think I saw a question specifically about. Oh, that's the chat. Where's the Q&A questions at? Guess I can't view those while I'm in presentation mode. Um, I was just thinking I can already I can start the Q&A session now because I before I started I saw a question about the OH stretch mode and to describe it a little bit more significantly in a little bit more detail. But basically, so the OH stretch mode. There's actually several different kind of ways that this uh, uh, oscillator can stretch. Symmetrical stretching, asymmetrical stretching, wagging, twisting, rocking, all kinds of these dynamic modes. This is occurring at like terahertz and above frequencies. So I don't know what this would actually look like physically. If you could see a water molecule, it would probably look kind of like a spinning vortex, actually, all these motions together. So going back to just simplifying it as a linear oscillator, which is equivalent to one with vortex, a spinning vortex. The thing is that with greater energy levels, so what's being depicted on the y-axis here, you get greater diameter, greater radius, this in nanometers, this is being depicted on the x-axis here, of that stretch mode, the length at which it's stretching. So with greater energy contribution, so let's say energy coming from the 0 point energy transferring into this oscillation, that dipole moment is going to increase. It's going to get stronger. So we can see that our computed value for the hydronium atom at 9.11 times 10 to the 13 hertz is remarkably close to the measured value. This is the measured value of the oscillation of the OH stretch mode. Our value is nearly equivalent to what's measured. But when you have energy being supplied into that OH stretch mode, you're going to increase the strength or at least stabilize that dipole, and hence the overall dipole moment of your water molecule, and hence increase the hydrogen bonding strength of the hydrogen bonding network here. Not only how much strongly the water molecules interact with themselves or auto interaction, self-organizing dynamic that leads to the formation of coherence domains of water, what is kind of uh, imprecisely called like structured water, but also intermolecular interactions, how much more strongly water is going to interact with other molecules. And if there's this ZPE term coming in, to this interaction, we can see how it's a low entropy, negentropic converter that is lowering the entropy of these systems that are aqueous systems. And so that's going to lead to like organization of other molecules, other solutes in the water environment, and that's what we're going to describe eventually is how that precisely leads to the formation of living systems of life. That's one of the discoveries that's been made recently, which is just very exciting. And after we had discovered this, via just calculations, I saw this paper where they're measuring how the contribution of zero point energy stabilizes hydrogen bonds and intermolecular interactions. This is a paper that was published in Science. It's a very interesting measurement that they found, a result that they found, because they find that there's this intermolecular interaction of ZPE, zero point energy interaction, that destabilizes the hydrogen bond, but then this intermolecular interaction that stabilizes them, and they're about equivalent. But so what we're thinking is that under certain, let's say, density conditions, certain conditions favoring more coherent interactions, there's going to be a greater influx of that ZPE energy via our Planck coupling constant mechanism that stabilizes hydrogen bonds, leading to increased hydrogen bonding network strength and activity, which is essential for biological organization and function. So we have demonstrated so this critical mechanism for self-organizational dynamics driven by energy transfer from quantum vacuum fluctuation, low entropy. As our findings demonstrate how ZPF coupled vibrational excitation of water leads to enhanced dipole moments, dynamic polarization, and the stabilization of coherence domains. These effects not only increase molecular reactivity and electromagnetic coupling, but also create the physical conditions necessary for quantum coherence in biological environments. So we uncover a key mechanism for quantum vacuum fluctuation mediated self-organization in aqueous systems, finding the water molecules in strong hydrogen bonding networks comprised of hydronium ions function as effective antennae for zero-point field modes, resonating with the OH vibrational mode, remarkably close to the measured value from our computed value. The resulting increase in dipole moment enhances water's ability to polarize neighboring molecules, thereby facilitating long-range coupling and the emergence of mesoscopic coherence domains. And we believe that this is this zero-point field coupling, the OH vibrational mode, could lead to like phase locked amplification potentially under certain circumstances, but it's instrumental in going from the uh, high coherence domains of quantum vacuum fluctuations to molecular organization and then leading perhaps to life. The kind of organizational dynamics that enable the living system, since these high coherence domains are like negentropic converters. They're the source of the low entropy, in addition to like the sun, that is driving the molecular organization that supports the dissipative system that is the living system of life. So linking electromagnetic quantum oscillations to coherent water dynamics in biological systems. So we've demonstrated a multiscalar resonance chain linking Planck scale vacuum oscillations to coherent molecular dynamics in water and biological systems through harmonic coupling mediated by universal Planck coupling constant. We show that the vibrational energy from the quantum electromagnetic vacuum can be transferred across scale from subatomic structures to the mesoscopic domains of water and macromolecules via a nested system of coupled oscillators. This offers a plausible mechanism by which coherent quantum fluctuations at the foundation of spacetime can influence biological order. The unified model suggests that life exploits a deep physical order, tuning into the vacuum itself. to optimize energy transfer, information processing, and organizational stability. It opens a new frontier in biophysics where quantum field theory, relativity, cosmology, or just a general unified physics and molecular biology converge and offers promising implications for fields ranging from consciousness studies to quantum biology and potentially regenerative medicine. So thank you all for entertaining my presentation and following along with me. And I think we have a little bit of time here for some questions or even just general feedback. So now I can access the Q&A now that I've stopped sharing. I didn't see it before. Can you detail the coupling mechanism between the OH bond and ZPE? Um, and so, this is admittedly a recent breakthrough, a recent discovery, like in the last couple of months. So this is very much a developing investigation, but I think that most simply I can describe this as uh, that the proton, the same way that it's a particle, a source particle for the electromagnetic interaction, a source particle for the gravitational interaction. It's a source particle for an entropic force that is a transfer of low entropy, that's high information, high energy, low entropy uh, state that is the high coherence region of Bose condensate region of the quantum vacuum fluctuation energy density is a source particle for this negentropic force that is a transfer of that low entropy into larger systems, especially dissipative systems that are like the foundation for a living system. And so transferring this low entropy, that's high energy, high information, causing a phase shift so that it goes into a organizational state, the self-organizational state with that provided energy. And it's not so different than explaining the effect of sunlight. The sun is a low entropy source. In a certain sense, it is a source object for low entropy transfer. That's mainly what the sun is doing. It's providing low entropy states for all these dissipative systems on the surface of the earth that comprise the biosphere, and that is the source of life. But what we're discovering here is that it's not the only source. And what is the sun? But it's a collection of many protons that they come together, and then you get a really low entropy state, and that's the source of life in the universe. But not the only one, because it's coming ultimately from protons, and so even the protons, many black holes in water, are a source for this low entropy that is ultimately high coherence phases of the quantum vacuum. That's the ultimate source of neg entropy, low entropy source, even for stars. That's ultimately where they're drawing that low entropy from. The water, the OH bond, which is a proton coupled to oxygen, uh, it has that oscillator, the proton oscillator, and it's possible that it is acting as that source particle for the negentropic field, for this entropic force that is a organizational force, which is really just a transfer of zero point energy um, into the vibrational oscillatory frequency activity of these oscillators. which we saw at the beginning with the mathematics that if you remove that ZPE term, the dipole of these oscillators collapses. So we know that the ZPE must be there providing energy. And so that's occurring in the OH bond, maintaining that partial dipole moment of the water molecule, which makes water the universal solvent, which is why water is the medium of life, is because of this partial dipole moment that is supported by the ZPE. That's that science paper even that I showed where they're measuring how ZPE contribution stabilizes the hydrogen bonds of water. And hydrogen, of course, is a proton. And so what we're investigating now is how you can have this ZPE coupling or vibrational energy contribution potentially increase at harmonics of that OH stretch mode because the OH stretch mode it has overtones. So there's the ground state first harmonic, which is the values that I was showing for like the measured values and or calculated value, but it has overtones. So you can talk about the energizer activated OH stretch mode, which is going to produce a strong dipole moment. And what you see in that state is the water forms dimers. The two water molecules actually kind of bind together a kind of ionic binding, a hydrogen binding because of that activated OH bond. But so what we're investigating is, well, perhaps when you get a sufficient density of delocalized protons, or source term for this entropic interaction, negentropic interaction, it's contributing the ZP energy at like a 2x harmonic, an overtone that is phase locking with the normal OH stretch mode and activating it into a higher energy oscillation, hence a stronger dipole moment, and the water forms its coherence domains. And this is what you might call um, structured water. But not in the sense I would stress of like a static geometric structure. That's ice. That's crystal, but more like a liquid crystalline state, right? So where there's some dynamic oscillation. So that's something that we will discuss in more detail as this investigation gains more clarity because this is some really recent work. But the good news is that what I've just presented is going to be published. I don't know exactly when, but it'll be published in the proceedings of the fifth Aquaphotomics conference. So that is going to be something we're working on and we're looking forward to. So we'll have this provided to you in detail, and it'll probably be even fleshed out a little bit more than what I've presented here. But you know what, the reason that I'm confident in presenting it, even at this early of a stage, is that those values are specific. I mean, they are getting very close to what is measured values across 34 orders of magnitude. So we're not dealing with a coincidence here. um, there's a specific mechanism that is being elucidated here. And there's no doubt that this is going to be a significant um, mechanism in understanding the behavior of water in forming coherence domains and organizing, acting as the medium and the message of biological systems of the cellular environment. Okay, so I'd like to uh, uh, take even one or two questions and hear from you directly. Uh, at the top here, I've got our good friend Jeffrey Colebrook. Let me see if I can bring you on. Uh, let's see, is it Jim G? I thought I hit Jeffrey Colebrook. Are you going under the alias of Jim G? If you unmute, you can talk. I don't know if you can enable your.
Hello,
Uh,
this is Jim G.
oh, okay. I guess
And
Okay,
I'm
Jim.
not I'm not Jeffrey, but we know
I
each other.
okay. I thought actually. Oh, okay. I thought I selected Jeffrey. I don't know exactly what happened there. Uh, uh, I don't mean to put you on the spot, but since I have you up, any
We
questions, comments, feedback?
Well, just a big thank you.
Okay.
I wrote that this is integrating all my coupling oscillators, so it's enlightening.
Awesome, awesome. You're getting some real-time synchronization there, and alignment. Awesome.
So
Uh,
great work, thank you.
okay. Oh, thank you, Jim. So sorry to put you on the spot there, but thank you for sharing with us all. Uh, okay.
I
Jeffrey, I
think
think I
yeah,
got you now.
all right. Yeah, I'm unmuted.
Okay, okay.
uh,
Uh, you were saying you had one of our, I guess, ISF member groups that you host had a discussion on AI. Uh, sparked by he found randomness in AI that allows for communication with AI as consciousness. Um, I could let you elaborate a little bit on that. We don't have a whole lot of time for questions, but um, I would just say that that uh, is very significant to me because in w my work on describing what is the state that what is one of the primary characteristics that we can use to identify a system as aware. One of the states that I've identified that as a requirement is a level of, you could say, randomness, or at least indeterminism, but actually more specifically going back to Roger Penrose's supposition from like 1980, non-computability, non-predictability, a non-algorithmic aspect to the system. Let's say it's an information processing system. We're information processing systems, but we're not digital computational systems. Because at the core, at the foundation of our information processing is a non-algorithmic information processing property. And actually, in next month in Barcelona at the 2025 uh, Science of Consciousness conference, I'm going to explain specifically this non-algorithmic property.
Mm.
And how it functions in the biological system, and how that is foundational to a real genuine sentience that is not the result of computational functionalism. It's not the result of a digital computational scheme of on-off states. So
yeah,
the fact that Adam is saying that he's discovered this kind of randomness in AI, that would be when I hear that, I would say, okay, that is a state that is conducive to real consciousness or awareness.
yeah, that was we had a fascinating discussion, and I had first actually hadn't had anything to do with AI chat, but I did ask AI chat why it couldn't cross-reference from multiple disciplines, and it says it just hasn't been developed that way, where it could actually compare all like the biology information that supports a unified model and the physics model and everything else and correlate them. And but it did suggest that it might be able to, but it needed a whole nother development. It just can't it can't go from a narrow objective view to a larger objective subjective view. And so we had a lot of fun with that. And again, Adams, it's going to be interesting because um, as you say, you got this conference coming up. And all I can say is we had a delightful time talking about it, and I think it's a wonderful subject, and thank you for taking time to bring this subject into today's discussion. A wonderful discussion. Thank you. Thank you very much.
Oh, thank you, Jeffrey. Yeah, yeah. Which chat GP I'm sorry, which AI were you talking with? I actually already started to name one of them.
Well, it's Chat AI.
Oh, okay, okay.
I think I might have even emailed you at some point the result I got, which was
Oh,
kind
okay.
of fascinating. So you can
You
check
know,
that.
I'm doing a catch up on my emails, so actually I don't
Yeah,
know if
no rush.
I've seen it yet. Yeah, good because yeah, we had this conference which was just like 5 days nonstop all day long, looking at the science of aquaphotomics. We were looking at how it applies or how it could even be better understood via some of the physics solutions that we're looking at. So actually I'm a little bit behind on my emails, but
Well,
I'll look for the one you sent.
well, this was interesting because I had no experience with AI,
Oh,
until nothing. I hadn't done anything with it until our little group met on Wednesday and we started talking about it. So I thought, oh, I'll play with it and put something in and ask it why everything is quantified. I mean, everything is like, well, we don't really know. We really don't know. They can't seem to make a bigger cross-reference evaluation. And I asked it that, and it said it just couldn't do it at this time. So that was kind of fascinating. But thank you again, William.
well, thank you, Jeffrey, for bringing that interesting consideration up. So I think we got enough time for one more question. So I see a hand up. This will be I'm not exactly sure what the nature of the question will be, but let's see, Rudolph, if you still are interested
Yes,
in asking your question, please go ahead.
I'm here. Can you hear me, William?
Yes, I can hear you.
Perfect. Yes, I wanted to thank you for this presentation. I wanted to know a little bit more about what happens after the aqua photomics because I know leading up to it, people were really excited that Nassim was going to present unified science, and there were talks that it's going to unify like they've discovered a lot of different applications, but there was no unifying theory. And then they thought, okay, maybe unified science would be the theory that kind of brings everything together. So, because we don't have much details on what happened at the conference, I wanted to hear, maybe how people received it, and is there going to be collaboration? What happens next with
Uh, Oh yeah. I'm so glad you brought this particular aspect up because it was really kind of a pivotal moment in the work of Nassim Haramein because he was presenting the unified physics at a university. We were there at Kobe University in Centennial Hall, and so it was just such a invigorating experience, energizing experience because there was professors there. Uh, PhD grad students, physicists, like physicists that are working on new novel theories, physicists that have been working on theories for 30 years. One in particular that comes to mind is Giuseppe Vitiello, who is actually a really profound, prolific physicist who's done a lot of work on the QED application to understanding water dynamics, but also has done a lot of work even on things like science of consciousness. But so Nassim was definitely the star of the presentation, and that's not hyperbole there. So he was very well received, and actually it was just a very warming kind of even heart-filled experience to get to share this information and then receive the feedback from this group of really brilliant researchers, many of them from academia. I mean, from Kobe University, from universities in Tehran and Milan. It's interesting because a lot of the researchers, the physicists that we were talking with, are from Italy, because one of the breakthrough, or I should say actually groundbreaking theories for understanding the quantum physics of water came from uh, um, these Italian physicists, Emilio del Giudice and Parada. And this was back in the early 80s, so over 40 years ago. But then there was a whole, almost like a field that developed from their discoveries, their groundbreaking work, which included like Giuseppe Vitiello and even some newer physicists. Now, one of the things you would ask is, so what, bringing this physics in, is it helping to develop a unified perspective, a unified science around aquaphotomics? And indeed it is, because there was this groundbreaking work which is looking at a QED, quantum electrodynamic formalism for describing the behavior of water. And one of the key features of this is describing how bulk phase water can undergo a phase transition when it interacts with the quantum vacuum energy density and form these coherence domains. And this is what
Oh,
people probably more typically in the layman terminology call like structured water.
okay.
But because they're using QED, quantum electrodynamics, which is not unified physics, uh, the quantum vacuum description in QED is random. So the entire description of the formation of these coherence domains is based on randomness. That you've got these quantum vacuum fluctuations that are just all over the place. I'm going to speak kind of loosely here,
Yes.
but every now and then you get mode, a ZPF mode, zero point field mode, which is the energy of this quantum vacuum oscillation of this photon that matches the resonant frequency of a water molecule, and it's absorbed. So even though there's a large amount of random quantum vacuum fluctuations that don't do anything, don't interact with matter at all, every now and then you have this interaction, and this can lead to like a self-amplification mechanism where the water emits that photon that's then absorbed by another water molecule that emits it, and then at a certain critical phase, this random absorption of photons from the quantum vacuum energy density can lead to long range collective coherence, basically a phase transition, symmetry breaking of the water molecule into a high coherence domain, a coherence phase, high coherence phase. But it's based on randomness. It's this within that approach, within that formulation. What we're going to describe, though, is how it's not random.
Okay.
Actually, how uh, there is a very specific mechanism by which you get ZPF coupling, so that you get zero point energy transfer into these into the OH stretch mode of these water molecules, increasing the dipole moment, and so that it's actually under many conditions driven in a non-random fashion for water organization to form these high coherence domains. And so that's going to be a key piece of the puzzle that we were able to immediately see the application of that understanding because one of the main points of the origin of mass and nature of gravity, so some of this latest work that's come out via like the correlation functions, is how we can describe high coherence phases of the quantum vacuum energy density.
And if we know that it's not random, that means we can control it, right? I mean, that's where all the applications
Exactly.
will come.
Yeah.
Okay. Okay. Perfect.
Exactly.
Thank you.
You hit on one of the most exciting points, because as we're seeing how this uh phase shift, this not so spontaneous symmetry breaking, going into like a liquid crystalline phase of the water, as we're seeing how this is naturally occurring, and actually favored to occur, we see that exact mechanism. We can technologically augment that process, and that's one of the things we're going to be uh, investigating the application of that almost immediately.
Okay.
Yeah, yeah. Great insight there. Yeah.
Okay. Thank you very much.
Thank you. Thank you, Rudolph. Uh, yes, very much appreciate your feedback there. Okay, well, I guess just one last time, thank you all for joining us, and I hope it was a informative session. Hopefully, I got some wheels turning, and we'll all be thinking about some of this in greater detail, so that as it develops, I can share more of the progression of these discoveries, so that at our next session, I think it's going to be really exciting to build upon what we've discussed today. So I hope you can join us for the next session. Until then, please take care. May the vacuum be with you. As we've seen, this is a tremendous source of energization so, and organizational synergy. So really, may the vacuum be with you. And I look forward to the next time we get to come together to discuss these fascinating topics. Thank you all. Bye.